So a big welcome to a very interesting topic and subject today. We're looking at science and Christian faith, and we'll look at reasons for belief. We'll look at the relationship between science and faith and what it means for us. It's interesting that science and faith for us as Christians often have to work together. That is, science is part of the world in which we live, and then faith is important as well. And science and mathematics might ask what and how and where and when, but it's faith that asks who relationally. It's faith that asks what is the meaning, what's the reason for existence. And just as people need a sense of meaning for existence, the universe, our world, communities around us all need a sense of meaning. And prayer and religious practices can help give that sense of meaning. So let's begin today's class on science and faith and critical thinking and effective learning with a Bible reading from Psalm 19. The heavens declare, says the psalmist, the glory of God, and the skies proclaim the work of his hands. Day after day they pour forth speech, and night after night they reveal knowledge, even as we look up at the night sky. They have no speech. They use no words. No sound is heard from them, and yet their voice goes out into all the earth as we look to the stars or look to the world around us. Their words to the end of the world, and whatever island we're on, people can see the heavens and the earth. It's like a bridegroom coming out of the chamber. In the heavens, God has pitched a tent for the sun, like a champion, rejoicing to run his course. It rises at one end of the heavens, makes its circuit to the other. Nothing is deprived of its warmth, the warmth of the sun. And the law of the Lord is also perfect. It refreshes the soul. And the statutes of the Lord are trustworthy, making wise the simple. And Psalm 19 goes on further to describe the benefits of the law and the word of God. Let's open with a prayer. Lord, we know that you, as our creator, have chosen to reveal to mankind, partly through scripture, but also partly through the biological and physical sciences around us. You give us limited insights into the processes in the world that you've created. And Lord, we know, due to our sinful natures, that we've often taken this information, we've overlooked it, we've not been as wise as we can. The information that you've so graciously revealed, we've sometimes used to elevate our own intellectual pride rather than glorify you and help one another. Lord, so that we may be humble before you, we ask that you direct our study, our research to reveal the information that you may be using to glorify you as our creator. And we specifically pray that this learning and information today will be useful for us, and it'll help us as we communicate science and scientific method to others. And we pray it'll help people to realize their dependency on you, that you're unchanging, that you are the ground of all being, and that your scriptures are also an unchanging revelation to us. This is our prayer to you today. So we're looking at science and its benefits to us. But before we start, can I ask each one of you to write down, what is science? What do we mean by science? And we'll begin to think a little bit about some of the different ways in which people understand science. And what does science mean to us? So what is science? What do we mean by science? What does it mean to us? And does it mean different things to different people? Does it mean different things to Christians and to those who don't have a faith in God? So we'll give some thoughts in the lesson today as to what is meant by science. Peter Harrison has said sometimes it's thought that modern science developed independent of Christianity and religion. Some even have thought that modern science developed as an antagonism, a freedom from religion that held people back in the dark ages. Alex, what do you think science means? And then Alira.
Well, science, to me, when I think science, I think of, I guess the thought, I guess it's a study of how everything in this world works. I guess that's my initial thought.
Yeah, sounds good. Alira.
Isn't it like the structure and behavior of particular physical, and it's kind of like a natural approach to the world, like a naturalist approach, rather than a fully faith-based. Sure,
and sometimes it's called natural philosophy because it looks at natural aspects of the world. Gabriella and Sally. Gabriella, what do you think science is?
My first thinking was just how science is basically looking and observing and making conclusions, I guess, about what we see around us and how that has either come to be or how, I don't know.
I think that's an important one as to the major way that we find out about the world around us is by what we see. And when we come to the telescope and also the microscope, they're helping us look at the world in further. And so I think observing and then describing and then repeating through experiments is going to be important. Sally?
I'd say science is kind of looking at the measurable parts of the world, the testing, the things that you don't necessarily need to just accept that exist.
Yes, can you tell us a bit more about testing and experiments? How would you be able to test an experiment rather than just accept? And I guess if someone says you need a medical treatment or something like that, you'd want to know what are the tests rather than just follow, might be your aunt or grandmother who says, just take this, eat more olives or something like that, whereas science would say, no, there are set tested ways. Yeah, what are your thoughts on testing and experiments?
I don't know. I think it's just understanding how things work better. So it's finding the errors, if it is like medical, how different elements interact with each other.
Yeah,
I'm not
so good.
sure.
Yeah. Kieran, your thoughts? What is science?
Science for me is just understanding the natural phenomena around us. Just figuring out what's going on.
Yeah. Yeah. And certainly I had an experience with one of our family members developed a leukemia illness about 10, 15 years ago. And the treatments that they use for that now, they had about 85% of people would pass away from it. But in the 1980s, about 1985 to 1990, they combined 3 different treatments and they'd experimented with these and developed these treatments. One of them was to pump arsenic through the bloodstream, and arsenic can do you damage, but in this sense, it wipes out the DNA producing new blood in the body, and then the body has to recharge itself and start the mechanism again. And fortunately, in this case, it worked, and the body got it all going properly again. And so it's these experiments that combine 3 different treatments that are tried that they now know are able to do a very effective job with this form of leukemia. And so instead of 85% of people dying. They now have 85% or more people surviving. And so it's understanding the natural world, how illness works, how cures work, and also understanding. And every patient now in the hospital, they take detailed records because every patient is a further experiment. And sometimes they'll adjust just a small amount, increase in one treatment or decrease in one treatment, and then record what happens. And so they have this accumulation of huge amounts of information every time someone is being treated. So Peter Harrison from Oxford University and University of Queensland says that there is a view that science is just measuring things, but is this independent of religion? Is it free of religion? Peter Harrison says the opposite is true. As a matter of fact, it's often connected to religious beliefs. He says that you'll get books when you're teaching that'll say, like a website, nobeliefs.com, that science was there with the ancient Greeks. And then when the Catholic Church rose to power in 300 or 400 or 500 AD, we entered the Dark Ages when people became religious. And then after 15, 16, 1700, people became scientific and free of religion. What they forget is that the Greeks were religious. So they were scientific and religious. Plato, in particular, was religious, and Aristotle, too, speaks of God. So the ancient Greeks were religious. And what they forget is that many of the great scientists, like Kepler and Copernicus and Isaac Newton, were also religious. And so you can't simply say that science is separated from religion, because so many people who are scientists have been religious. And even today, many scientists are Christian. Carl Sagan produced a TV series, the Cosmos series. And here again, he said that the Greeks flourished in science, forgetting that they were also religious. And then along came Columbus, Copernicus, Kepler, etc., and people became scientific. What he forgets was Columbus, Copernicus, and Kepler were both driven by their religious faith in their scientific endeavors. So we need to be careful when we try and explain what science is, that we don't start with a general theory like science is freedom from religion, and we need to recognize that science and religion can have a complex interaction. One of the reasons, says Peter Harrison, that some people talk about freedom from religion leading to science is because the Protestant Christians under Martin Luther wanted to attack the Catholic Church. And so the Protestant reformers said the Catholic Church were stopping, hindering science and knowledge. So it was more their sales pitch, it was political. Francis Bacon, who was a key figure in the development of science, was also a Protestant reformer. So he's speaking about Protestant Reformation, which is one of the reasons why people talk about freedom from religion, and one of the reasons why they attack Galileo and say Galileo was a great thinker. Galileo also expressed his Christian beliefs, and as we saw last week in mathematics, Galileo said mathematics is the language of God, that's why he's interested in it. So Galileo had Christian beliefs, and the Catholic Church sided with the scientists of the day that said Galileo hadn't provided enough scientific information, and it was only about 20 years or so after Galileo that the scientific information came in to support Galileo's ideas. So all around us, science is about the natural world, and the natural world can be seen as part of God's revelation to us. So Christians are often quite excited about the study of the natural world, because that's the world that's around us. Some students have asked me, is science and maths methods of study, or are they fields of study? And the answer is both. So maths is a method of study, but it's an area of study, subject in its own. Science too is a method of study, and it's also a field of study. So science can refer to the field of study of the natural world, And there can be the physical sciences, physics, motion, energy, potential and kinetic energy, friction, similar to what we looked at last week with maths. Physical sciences, physics is similar to maths. Chemistry takes us further into the nature of the chemical elements. And chemistry is old in that the study of iron and copper goes back into ancient times. And then other chemicals have been looked at through the ages, carbon and other chemicals. And then there are other chemicals that have been discovered more recently. Geology, study of the rocks back in ancient times, you'd use that in building, but in more recent times, geology has developed into a whole area of study further. Meteorology, very important in ancient times. Oceanography and the sea, important in ancient times, but there are new ways of looking at these things today. The life sciences too have been important in ancient times, and there's new ways of looking at the life sciences today as well. So science can refer to both the methods, but also the areas of study. So there's branches of science, including the natural sciences, looking at the natural world, the physical sciences of physics and chemistry, of the substances that we engage in, and then the study of the earth, the ground, astronomy, the stars we see in the sky, meteorology, the weather, and the oceans. And then there's the life sciences, botany, the plants, and that's where I did some of my first studies at university. And then zoology, the study of animals, genetics, and ecology. And I went on to do those studies at university before I went into science teaching. So physical science is chemistry and physics, and we look at what the world is made up in terms of matter. And in ancient times, they sought to understand the physical world around them, and they made concrete and they made liquid metals. And we still do similar things today in some ways. And then earth science looks at the rocks and the ground around us, and also looks at volcanoes and how these come to pass. And then biology I really loved, because you can study the living plants, you can study the living animals, you could get a job on the barrier reef swimming with the fish, and they pay you to do that. I know two people at the moment who are being paid to swim with the fish on the barrier reef. That's a good job. Scientific laws. So just as there are laws in a country, and just as you read in the Bible about the laws of God, there were Christians who talked about natural laws, that God has also put laws in the universe. And Isaac Newton talks this way about the God who gives us the physical laws also gives us the spiritual laws as well. And so we see there that these laws can describe the patterns in nature that are observed repeatedly. So any thoughts, Alex? What is a scientific law? What sort of things does it refer to? And then Sally after Alex, if she's got any thoughts on what a scientific law is. Alex, what's a scientific law?
I guess if we're saying that science is the study of the natural aspects of the world, then the scientific law would be relevant to I guess the actions or the processes of the world and how they work and how things work.
Interestingly, if they talk about how things ought to go, who's the lawgiver? Who sets the laws in place? And so the word scientific laws begins with people thinking religiously. Sally, your thoughts on scientific laws?
I don't think I have anything to add at this point. I'm sorry.
And that's good. Kieran, your thoughts on what's a scientific law?
Yeah, I suppose scientific laws are just this way that a certain thing has to behave based on what we've observed it to be consistently doing. And they're often more discovered than they are written.
So interestingly, people like Isaac Newton, who came up with laws like laws of gravity, were often motivated by their Christian belief to think about who governs the universe, who sets the laws in place. And we have a mission, mandate, and calling to find these laws. That is, God gives us freedom, God acts freely, and we are called to freely pursue an understanding not only of biblical laws to live a moral life, but scientific laws to understand the world that's around us. It's part of the call of God, the mission of God, as many of the scientists in the 1600s and 1700s said. So scientific laws are rules that describe patterns in nature, but this implies that someone has put them in place. And experiments are ways of testing our understanding of these laws. Data is where we collect information about these laws, and then models are where we come up with an image or an idea to show what these laws might stand for. And so people like Einstein has theories of what relativity might be, a relationship with energy and matter, and how they're related together. So he comes up with models, understandings to help us understand these laws. So scientific method is often about asking questions, coming up with ideas or a hypothesis, and then testing them with experiments, and then analyzing the results, and then formulating conclusions. And this can lead you to ask, what's religion got to do with this? So scientific method, you ask a question, you gather information, you come up with a hypothesis, you experiment, you analyze your data, you draw conclusions, and then you modify that. So that's a scientific method, and you can look up these steps in the scientific method. The exact number may vary, but it involves questioning, observing, testing, and then drawing conclusions from this. So you collect the information. You also look more widely at what others have said. You do a literature review of the material that's already existing. And then you talk to other scientists, you publish in conferences, you conduct experiments to test what's going on, you control all the other factors, so you just vary one factor at the time. You control variables, so you want to just change one variable, which is the independent variable, and then the other variables you want to keep fixed, which are the dependent variables. So these are different ways of understanding. What about stereotypes of scientists? Gabriella, what do you think of when you think of a scientist? Are there stereotypes of who scientists are? What do they look like?
I mean, initially I always just think of Albert Einstein with his big hair and his glasses.
Yeah, I wonder why. I guess scientists have a freedom to dress as they wish, and so they're not under the pressures of car salesmen or politicians to dress a certain way. And sometimes they dress in a very relaxed manner, don't they? So it's, yeah, I don't know why. Alira, any thoughts on stereotypes of scientists?
That they're very smart, I guess. I remember in school, the science teachers would often refer to themselves as being scientists and how we're all scientists, because we're all in some form of experimentation throughout our lives. And they would refer to God as being the biggest scientist of them all, as he created everything.
I love that. That's terrific. We're all scientists, and then God is the biggest scientist of all. There's other stereotypes about scientists, and I think partly comes from relaxed information. So why science teachers should not be given playground duty? They could experiment there with the kids. So science does involve observation, measurement, experiments, and laws. And this raises the question, who's the law giver? And they can be tested. They should be precise and exact. They should be backed by evidence. Science involves inductive logic, where you observe, you look at what's out there, and you test what you can see. And science can be tested through these means, and you try and avoid pseudoscience, which can't be tested. So science is open to criticism. It's open to careful, well-backed claims that are precise. It uses rigorous, repeatable methods, whereas pseudoscience, pretending to be science but not really being science, is hostile to criticism, uses jargon to confuse and evade, only picks little bits of evidence, and uses flawed methods that are inconsistent and invalid. So pseudoscience, you can't prove it wrong, makes grand claims, uses anecdotes, cherry picks information, technobabble, and plausible mechanisms. It exaggerates, it claims certainty when it doesn't have peer review, and comes up with conspiracy theories. So people come up with anti-wrinkle creams, people come up with phrenology, the shape of your head, people look to astrology, whereby your star signs will govern your life. But science is different. Science looks at evidence that can be verified. And interestingly, there's quite a lot of support for prayer being beneficial and healthy for people, and there is verifiable evidence for people having faith in the New Testament and in God. Science often focuses on experiments with the very material realm that's about, but also it can be about that which is more mathematical and we can't see, like Einstein and his 3-page paper, just 3 pages, gained him the Nobel Prize. And at the time he was working in a office, putting through patents for people, but on his 3 pages, didn't have bibliography, worked through what he was thinking. He was a civil servant at the time, gained in the Nobel Prize. Watson and Crick, working on the molecular structure of nuclear acids, came up with the double helix. Again, there's a theoretical aspect of what they're doing. So it's not always about what you can see and observe, which is Aristotle's pursuit. Sometimes it's also about ideas, which is Plato's unseen realm as well. Sometimes, of course, the Human Genome Project has got hundreds of people working on it. And so the bibliography is huge, very long list of authors, 240 authors, 15 to 20 research laboratories in 7 countries. So science can be very big. Model of the atom, they were wrestling through seeking to understand the atom when Rutherford sent beams flying in to the center of what he thought was an atom, and he found that rather than these other models, when it hit the center of the atom, which was very small, he came up with Rutherford's model of the atom. So it's not pseudoscience, there's evidence, it's open to feedback from others as well. So pseudoscience is when it's not true science. So we've just introduced a little bit of what science is about. Science can refer to methods used to gain an understanding of the natural world. Now, there is this tale that's told out there that we only developed these methods in the last few hundred years. Remember, when we were talking about the ancient Greeks, they used these sorts of methods back in ancient times as well. And so in some ways, these aren't just recent ideas. These are ideas that have been there for a long, long time. So over the centuries, through to modern times, people have been using maths. Last week we showed that mathematics was used by ancient people, and each generation stands on the shoulders of those who go before. So it's the accumulation of knowledge that gives us science. We spoke about the father of geometry, Euclid, living in ancient Greece, and people still use his book today. Archimedes, the Greek mathematician, he's the one who said you could use a lever to move just about anything. And he was one of the leading engineers and mathematicians of his time. When he was challenged to prove King Hieronymus of Syracuse that the wreath was made of pure gold or whether it had been covered with gold, he sat in a bath and realized that the water that flowed out would give him the exact volume. If he then compared that to the weight, then he'd work it out. So that was his eureka moment. So Archimedes, famous for showing that the volume of a sphere is exactly 2/3 of the cylinder that contains it. Back in ancient times, they used science to make water mills. They used science to talk about hygiene and latrines and sewage and arches and aqueducts to carry water, and making of concrete. Ptolemy described the movement of the stars. One of the things to remember is that in ancient times, the reason you wanted to understand astronomy and the stars was because you wanted to navigate or know the seasons or know when to put your crops in. That is, you looked up the stars not to find out what the stars were, but to tell you about the world here on Earth. So the stars moved in ways that would tell you about here on Earth. And when you look at indigenous people, they still look up to the stars to tell them about which time of year it is, what animals, what fish will be doing what. And so astronomy had a different purpose and meaning for indigenous people than it does for us. The Islamic people and Arab people also contributed to science and maths and the Hindu Arabic number system and algorithms for working through tasks and algebra flowing out of the Islamic Revolution. Over in England, has anyone been to England? Down in Bath, they have, so did you see some remains of the ancient Roman works in England while you were there, Kieran?
No, I didn't actually go to Bath. I was born there, so.
Yeah. What about in London? Have you seen London Wall, which is 2,000 years old, and it's in the middle of London itself? They've still got bits of Roman wall from 2,000 years ago. And yeah, so there's other bits of Rome. When I was in Germany, they've got bits of Roman walls here and there. So did you see any bits of Rome while you were in England, Kieran?
Not a lot. I know they've still got the Berlin Wall as well.
Yeah, yeah. So there's lots. So the Romans were famous for caterpillars. So their science was often about weapons, controlling variables to make dyes. And the Romans also, because they had gladiator fights, you then had to patch up the gladiators afterwards. So you had to be good at surgery, and they could do tooth work and all sorts of work. Caesar and Caesareans, that's people being opened up to give birth. So the Greek civilization and the Roman civilization and the ancient worlds had their form of science, and Hippocrates was an ancient healer of disease. So there was a lot that they knew in ancient times, and up until recent times, they used some of the descriptions by Hippocrates about the need to strengthen and build up the body's resistance to disease, the value of gymnastics and exercise and massage and hydrotherapy and sea bathing. Obviously, things have developed a lot in recent times, but there is also ancient treatments. And so I think it's important that we recognize that these ancient treatments weren't entirely absent. That is, there were doctors in ancient times who did this work in ancient times. The Romans also had techniques for operating on the eyes if you had cataracts, and working with that, plastic surgery, other surgical techniques. So I just want to point out that Galen's theory too, back in Greece and Rome, also has similarities to what is still done today. So the ancient world wasn't entirely devoid of these scientific methods. So scientific methods in ancient times like today ask questions about the natural world, although they'd ask about the weather and the stars. What's it going to be like if I'm going to take my ships out to sea in ancient times? They can ask that today and go to the weather report, and maybe the reliability is similar to today than it was. Maybe it's better. So they can ask questions: who, what, why, when, where, how. In science, we do literature review, where we gather the information about what is already known, and now we have 2,000 years of accumulated information, and we also look to more recent information. We construct a hypothesis, we try and work out what's likely to be possible. Then we carry out systematic experiments where we control what can happen. Then we analyze the data. And I thought, as an example, you could look at the science of making bread, and you could vary the different ingredients in the bread, and you could see how that changed what happened. And so that's the sort of thing they'd be doing 2,000 years ago as well. So as I said at the beginning, there's two views on the history of science. One is that science is freedom from religion and its analytical thinking, and you'll find that in about half the books you read. And then the other is a more realistic view, which actually says religion and Christianity has actually made some interesting contributions to science. And I said the reason for belief in a warfare with science is partly promoted by Protestants who wanted to show that you can't trust the Catholics. You can look at William Fowler's 1962 book, The Development of Scientific Method, and there he says that Dark Ages, everything stopped happening from 400 AD through to 1700, and then science came along and we're all much happier. David Wilkinson from St. John's writes, one of the real problems with the conflict of science and religion model is it claims that science and theology saying exactly the same things about the world, whereas it's way more complex. Science is looking at details of physics and chemistry and biology and anatomy, whereas Christian faith is looking at, tell us about God and what he's seeking to do in the world. Now, one of the things that you can do if you want to know a bit about science is go back to Aristotle, and you can download his writings, where he writes, all instruction given by way of argument proceeds from existing knowledge. So we observe and we describe. There is a knowing, a scientific knowledge, says Aristotle, that can be demonstrated, that you have a premise, a hypothesis, and then you go out and you demonstrate what's going on, and you observe, and you fall into error if you jump to a conclusion based on an individual case without looking at a lot of cases, comparing them and gathering your data. So some people say Aristotle was the first scientist. What I'm hoping to show today is that no, his science isn't perfect. Observing's not everything. So Aristotle did a great job in his science and science teaching in Athens, and his physics included description of levers and description of meteorology and description of astronomy and thunder and lightning and rainbows. All of these things were well described and were very useful. However, there was a weakness in Aristotle's approach, in that he said things just were because the clouds contained it, the lightning contained it. And this was accepted by many people from 1100 AD through to 1700 AD. And just accepting things are the way they are doesn't lead us to very good science. Peter Harrison writes, in contrast to Aristotle's ideas that you just observe and accept, other scientists like Robert Boyle and Isaac Newton followed Plato's idea that the universe is governed by universal laws installed by God, who gave us other laws, who established an ordered universe And he calls us to understand the ordered universe and the unchanging laws of God that govern our world. And it's the rejection of Aristotle simply observing and the acceptance that there are laws to be understood given by God that led to the advancement of science in the 16 to 1700s, says Peter Harrison, Prof of Religion and Science at Oxford and University of Queensland. Robert Boyle said, why do we study nature and discover gases? Because we're discovering the perfections of God in the world, the laws of God. So without this idea of pursuing what God has done, we possibly would not have had the great breakthroughs in the study of science that we had. For Rene Descartes, it's God recreating his laws in every part of the world that's rational, that's to be studied. For Descartes, it's God's constant willing for every object in the universe to follow his laws that makes it orderly, and we're called to study that. For Robert Boyle, the laws of motion require denying Aristotle, simply observing, realize that things don't just happen, but there are laws that govern it, and we need to understand these laws, says Peter Harrison. We've often forgotten the theological origins of belief in laws, and we just accept laws of nature and physics and chemistry without recognizing that it was Christian thinkers who looked to John Calvin and his commentary on Genesis, where he describes about the laws. So that's one aspect of the scientific contribution by Christians. Another aspect is sin. According to Aristotle, you just write down what you observe. But according to Blaise Pascal, if humans are sinful, describing what we observe, we may cheat. We may get it wrong. We're sinful people. How can we prevent this? By measurement, by using instruments to check and look more closely, like telescopes and microscopes, by using instruments to measure distance and speed, and then by publishing our results and getting others to check over them to make sure we've not sinned, that we've not been subsequent to the fall. Pascal said, we all possess an image of truth, but at the same time, the consequences of the fall and sin, we cheat. We're ignorant. Francis Bacon said the human intellect cannot be trusted because we're all fallen, sinful humans. So 2 points to remember from the Christian contribution to science. One is that Christians believed that it was a good world that was ordered, unlike Aristotle, who said it just was. They believed that there were laws that had to be studied and understood. And then secondly, Christians believe that because of the fallen sinful nature of humanity, we need to develop scientific methods that will check and double check and triple check and quadruple check and publish and test and get people to check and check and check, which is why the scientific method has so much checking in it. And experiments are ways of checking to make sure things are the case. And if you give all the details, anyone else can check that as well. Peter Harrison says it's this belief in sinfulness that led to an emphasis on telescopes and microscopes to make sure you checked what you were looking at. So you've got these different motivations in what is happening. Science has changed. Ancient people who looked up at the stars looked up because they wanted to know when the fish were going to come in, when the weather was going to change, when the seasons were going to change. There's been a shift that Christians who believed in science felt in the 17, 18, 1900s, they should also look at what God is calling us to understand about these stars. So they've moved from Ptolemy's focus, and this led Copernicus and Kepler to, they were Christians. Kepler himself was a canon in the church who also used mathematics to describe the movement of the earth around the sun, because he was rejecting Aristotle's approach of simply describing stars that were up there, and he was using mathematics and his ideas about the laws of God to describe what he felt God was calling him to describe. And so Kepler came up with the idea that the earth moves around the sun, because it was the call of God. So too Galileo felt that God had called him to use mathematics to describe the ways in which the planets moved around the sun, because it was part of the call of God. And so he used the telescope to describe that. And Isaac Newton used his maths to describe the laws of God. So in conclusion, it's this Christian belief in the laws of God that helped advance science through the 1600s and 1700s that gave us science as we understand it today. Science has come a long way. There are two stories told about science. One is that it's freedom from religion. And then the other, says Peter Harrison, is that Christians have also made a contribution to some very significant developments in science, like the ideas that there are laws that govern nature in a regular way, and like the idea that there are sins that can lead us to not declare the right thing. And it's helpful if we can understand this. So in drawing it together, we can argue that in looking at science, creation, according to Christians, is a good and ordered world, and we Christians are to be wise and to understand the natural world around us and to read it well and accurately, just as we're called to read Scripture well and accurately, and we have a mission call to read both Scripture and the natural world well. Secondly, because of our fallen nature in sin and ignorance and self-centeredness and hurtfulness towards others and focus on the self, we need systems of openness, transparency, accountability, testing, experimentation, hypothesis testing, repeatable, unbiased experiments that we share with others that critique these, and we have a mission to carry that out. So what stood out in this first session today? Kieran?
I think what stood out most for me is just how a lot of people, when we look at these old scientists and these well-known people, we're never taught about the faith that they had and what actually drove them for science.
Yeah.
And so I find it really interesting that a lot of these scientists did science because they believed it was faith-driven.
So good. They did science because of what they believed. Sally, what stood out to you in this first one? And then Shelley Ann. Sally, what stood out to you?
It was kind of just a weird, like even just a passing moment. I didn't realize how early like surgeries were being performed.
Yes.
Looking at like the cataracts and like the images of it, I was like, oh, that's really experimentation on people.
Yes.
So not really relevant, but very interesting.
I was in Cologne, which is where Cologne perfume and such forth comes from, and there's this beautiful cathedral there. When they built a museum next to it, they ran into a Roman city under where they were going to build the museum. So now they've enclosed it all in, but they discovered Roman surgical instruments. And so they have a little section there where they have Roman surgical instruments, and it's got scalpels and it's got scissors and all of those things for stitching up the gladiators after a fight, and cesarean, if a woman wasn't able to give birth, they'd open up the tummy and then they'd sew it all back together again. And so surgery's got a long history. Yeah. Shelley Ann, what stood out to you?
I was the same as the first person. Was it Kieran?
Yep.
Just just that little cheeky bit of knowledge that these famous scientists had faith is going to come in handy. I found that really encouraging. Thank you.
So good, Gabriella, and then Alira.
Similar to what Sally said, I think just the realization that what we're doing in terms of science isn't necessarily new. It's stuff that people have been wrestling with for hundreds of or thousands of years, really. I mean, it's new in terms of technology and all those sorts of different things, but it's just it's been, science has forever been a thing, sort of thing. I don't know, that was just a realization.
Yeah, and that's exactly true, isn't it? Is that in one sense, people are interested in the moon and all of that, but it's only in the last 30, 40, 50 years that we've been able to fly to the moon and get a few rocks. But in some ways, people have been asking questions, but their questions have been slightly different. That is, 2,000 years ago, you want to know about the moon to tell you when the fish were going to bite and when to plant your seeds, whereas now we want to go to the moon because we want to bring back some nice rocks or something. So it's similar but different. Alira.
Yeah, I agree with the realization that science is not so new. I know that it's been around for years and years and rediscovered by so many people in different ways. I just think that I just think it's really cool.
Isn't that interesting? It's expressed in different ways in different centuries. And so back in the 1800s, science gave us the steam train. So gave a lot of huffing and puffing, and you pour water in it to make a steam train work. And yet you could go back to Leonardo da Vinci. Science would help you make paint. And so every century you're using science to do something. And we live at the culmination of many centuries of science that have given us iPhones and things like that. So we have unique things today. Back in Roman times, they would have newspapers where they'd print, the leading politician of the day said, and they'd circulate that amongst the senators. And now we have iPhones to circulate the leading politician of the day said, and you'd circulate it. So there are similarities and differences between every age, and we need to acknowledge the similarities and differences. And then a major point a number have made is that scientists often had faith, and as Christians, it's helpful to understand that. So we'll come back after the break in 10 minutes' time, and we'll have a look further at science, critical thinking, and faith. Thank you.